For the following exercise, determine whether the relation represents y as a function of x. All right, so I listed some steps down here at the bottom left. The first thing we need to do in order to determine whether y is a function of x, is to first solve the equation for y itself. So I got to make sure that this thing has y alone on one of its sides, which it does not. All right, so that's going to be our first step. So we have to do some algebra. So let's write this out. So it's going to be x is equal to plus or minus radical 1 minus y. Now the first thing I like to do here, anytime I see usually plus and minus sign, is I want to separate this into two equations. All right, I want to separate it into the positive and into the negative. All right, and that will allow me to appropriately solve this. It'll should make a little more sense. So x will then be equal to square root of 1 minus y. And I'll put a little dividing line here. And then we also have x is equal to negative radical 1 minus y. All right, so now remember the whole goal is to solve for y, and I'm going to work on the left-hand side first. The whole goal is to solve for y. So I got to get rid of this whole mumbo-jumbo, the square root sign, right? So how do we get rid of a square root? Well, we have to do the inverse function, and that would be to square it. So if we square the right-hand side, we also better square that left-hand side. So what this works out to be now, this is nice. So this is just x squared is equal to 1 minus y. The square just cancels that square root, okay? So the answer is just whatever underneath that square root sign. Now this being the case, I can solve this thing for y, right? I can isolate y by itself. I want to get y to be positive. So I'm going to add y on over to the left-hand side, okay? And then simultaneously, I'm going to subtract then x squared on over to the right-hand side. All right, so that should give us, I'm just running out of space and I don't want it to be too messy. So that should give us something like this, that y is equal to negative x squared plus 1. Okay, great. So that takes care of the first one. Now, how about the second part? Well, it's the same process. I want to get y by itself, and therefore I got to square root the whole right side, including the negative. So I square that, and I'm going to square then the left. Now remember, if you take a negative sign and square it, it becomes a positive, right? And if you square a square root, it cancels that. So basically the negative cancels and the square root will also cancel. So now we're left with x squared is equal to 1 minus y. Oh, look at that. They're the same. That's wunderbar, right? So now we could just solve this for y, and then y is going to be equal to the same thing, x squared plus 1. So this is good. You don't have to plug this both into the calculator. It's the same thing. So now what we need to do, and you might not even need to plug it into the calculator, you might understand the nature of this function, right? It is a quadratic function. And therefore, right, you can just sketch a very quick picture. You don't have to be too detailed about this. All right, we know that it's going to be negative. You don't even have to really know that for this, but it's going to be negative, and therefore if it's negative, it's sad and it's a frown, okay? It's a smile turned upside down. So that being the case, we're going to have a graph that looks kind of like this. All right, and it's then going to, if x were 0, that whole term cancels, and then y would be equal to 1. So I know that this graph goes up to a value of 1. We don't really even need that either, but just so you know. All right, so now third step then is to test whether this thing is a function or not. We're going to perform the vertical line test. All right, so let me just copy the graph on over here so it doesn't get too messy for step 2. And now what I'm going to look to do is understand what the vertical line test says. And it says that if a vertical line does not intersect the graph more than once, okay, then the graph is a function. So I could draw a whole bunch of vertical lines. I draw a vertical line here, it only intersects once. I draw a vertical line here, it only intersects once. Vertical line here, only once again, etc. No matter where I draw this vertical line, it only will intersect this quadratic graph once. And therefore, since it only intersects the graph once, it is indeed a function. Okay, so the original equation that was given to us is indeed a function. Guys, thanks for tuning in. Please remember to subscribe, help us out, tell your friends, spread the word. We'd appreciate it so much. We got a lot of stuff coming to you. Thank you.